found left scientists stunned. Somewhere online right now, headlines are screaming that an interstellar object is on a collision course with Mars. That claim is everywhere, shared, reposted, argued about in comment sections. Here's the uncomfortable twist. It's already too late for that headline to even be true, one way or the other, because the object those headlines are talking about already passed Mars months ago, at a distance wider than the gap between Earth and the Moon multiplied more than 70 times over. No collision happened. None was ever going to happen. But the actual story, the one buried underneath that fake collision panic, is stranger, older, and considerably harder to explain than any headline claiming an impact ever managed to be. This is the real story of 3I Atlas, the object the James Webb Space Telescope turned its eye toward in 2025, and why a growing, deeply uncomfortable argument among scientists about where it actually came from still hasn't gone away. To understand why this object matters at all, you have to understand just how rare it is for something like this to ever show up in the first place. Every planet, moon, asteroid, and comet you've ever heard of, everything orbiting the sun right now, formed here, born out of the same swirling disk of gas and dust that built our entire solar system 4.5 billion years ago. They all belong here, gravitationally bound to our sun, following orbits that loop back around again and again, forever. 3. Island Atlas does not belong here. It was discovered on July 1st, 2025, and almost immediately, something about its path through space looked wrong. Every native resident of our solar system moves in a specific way, on a trajectory that closes into a loop, an ellipse bound forever by the sun's gravity. This object was moving too fast, on a trajectory shaped completely differently, a path that comes in once, swings around, and then leaves forever, never to return. Astronomers measured its orbit as retrograde, meaning it moves in the opposite direction around the sun, compared to every planet in our solar system, tilted at an angle so extreme that it crosses the paths of the planets almost like a needle threading through a stack of spinning plates, rather than joining the orderly, flat disk every native object obediently follows. That specific kind of trajectory has an unmistakable signature, and it told astronomers within days that they weren't looking at a resident of our solar system at all. They were looking at a visitor from somewhere else in the galaxy entirely, a wandering object flung out of some other star system, entirely unrelated to our own, that happened to drift close enough to the sun for us to notice it passing through. This has only ever happened twice before in recorded human history, and both previous times, the visit ended in frustration as much as discovery. The first confirmed interstellar visitor, a strange elongated object named Oumuamua, was spotted in 2017, already moving away from the sun by the time anyone noticed it, tumbling end over end in a way that made it briefly, seriously discussed. As a possible artificial object before it faded out of view entirely, its true nature never fully resolved. It vanished again before scientists could gather more than a fraction of the data they wanted, leaving behind more open questions than answers. The second, a comet named Borisov, passed through in 2019, behaving much more like and too briefly through range for anything beyond a limited window of observation. Both encounters were treated as once-in-a-lifetime events, discussed for years, afterwards specifically, because nobody expected a third one to show up anytime soon. Then, 6 years after Borisov, a third one showed up, and this time, astronomers were far better prepared to actually study it while it was still here. Survey telescopes built specifically to scan large portions of the sky every single night. Technology that barely existed in any meaningful form back in 2017 caught 3I Atlas early, while it was still far enough out that researchers had months, rather than days, to plan a genuine observation campaign. That preparation is exactly why the James Webb Space Telescope got involved so quickly. On August 6, 2025, just over a month after 3I Atlas was first spotted, Webb turned its near-infrared spectrograph toward the object, catching it early enough to study its composition before it made its closest pass by the sun. What Webb found was strange enough that scientists went back for a second, deeper look in December, after the object had already swung around the sun and started heading back out of the solar system. Here's what makes those readings genuinely unusual. Comets are essentially dirty snowballs, chunks of ice and dust that heat up as they approach the sun, releasing gas and dust into a glowing cloud called a coma. Scientists already know, from decades of studying comets that formed right here in our own solar system, roughly what that gas cloud should be made of and in what proportions, built from long-period comets and Jupiter family comets that have been observed and cataloged for generations. When Webb analyzed the light coming from 3I Atlas's coma, using its near-infrared spectrograph to break that faint light apart into a detailed chemical fingerprint, it found carbon dioxide gas in a ratio to water that was far higher than almost any other comet ever measured, so far outside the normal range that researchers described the imbalance as several standard deviations beyond nearly every comparable comet in the historical record. Alongside that carbon dioxide, Webb detected water, carbon monoxide, tiny grains of water ice, fine dust, and a tentative signature of a sulfur-based compound rarely confirmed in cometary comas at all. Scientists have a working explanation for why that particular imbalance might make sense if this object really is as ancient as its trajectory suggests. A comet's chemistry gets locked in place at the moment it forms, frozen into whatever ices condense out of the specific gas cloud surrounding whatever star it happened to form near. If 3I Atlas really did condense billions of years before our own sun existed, out of a completely different reservoir of gas and dust than the one that built our solar system, there's no particular reason to expect its chemical ratios to match the comets we're used to studying here. In that sense, the strange proportions Webb measured aren't necessarily a red flag suggesting something is deeply wrong with the natural explanation. They may simply be a fingerprint, a chemical signature carried unchanged across billions of years from a star system at a moment in galactic history that no human telescope has ever been able to sample directly any other way. Put simply, whatever this thing is made of, it wasn't built the same way the comets orbiting our own sun were built. It formed somewhere else, under different conditions, around a different star, long before it ever became our problem to study. Even something as basic as its actual size turned out to be surprisingly hard to pin down. When the Hubble Space Telescope observed the object in July of 2025, researchers could only narrow its nucleus down to somewhere between roughly 440 meters and 5.6 kilometers across, an uncertainty range wide enough to fit a small hill on one end and something the size of a mid-sized city on the other. That kind of uncertainty isn't a failure of the instruments. It's a side effect of studying something faint, distant, and shrouded in its own cloud of gas and dust, where the glowing coma surrounding the nucleus makes it genuinely difficult to know exactly where the solid core ends and the surrounding haze begins. And the age of the thing makes that difference even harder to casually explain away. Based on its extreme speed and trajectory, researchers estimate 3IR Atlas could be anywhere up to 10 billion years old, potentially making it the oldest comet ever directly observed by humanity. For context, our entire solar system, the Sun, the Earth, every planet you've ever heard of, is roughly 4.5 billion years old. This object could be more than twice that age, meaning it may have condensed out of gas and dust during an ancient, violent period of intense star formation across the Milky Way, sometime between 9 and 13 billion years ago, long before our own sun had even finished forming. Picture what the galaxy actually looked like during that window of time, because it helps explain why scientists find this particular estimate so striking. 9 to 13 billion years ago, the Milky Way was still young and chaotic by its own standards, churning through gas clouds and forming new stars at a dramatically faster rate than it does today, a period some astronomers refer to as galactic cosmic noon. Countless stars flared to life. During that era, many of them short-lived, many surrounded by their own disks of gas, dust, and forming comets, in systems that have since burned out, drifted apart, or been torn away entirely by the gravity of passing stars over the following billions of years. If 3I Atlas really did form during that specific window, it would mean this one small, icy object has managed to survive, drifting alone through interstellar space, longer than the star system that originally created it. If that estimate holds up, every fragment of ice inside that object has been drifting through interstellar space, silent and frozen since a period in galactic history so early that our own sun didn't yet exist to watch it happen. So where does Mars, and that fake collision headline, actually fit into all of this? As 3I Atlas moved through the solar system on its one-way trip past the sun, its path happened to carry it just inside the orbit of Mars, close enough that multiple spacecraft, already stationed around the red planet, got a genuinely rare opportunity. On October 3rd, 2025, the object made its closest approach to Mars, and both the European Space Agency's ExoMars Trace Gas Orbiter and its Mars Express spacecraft turned their cameras away from the Martian surface they were built to study, and pointed them instead at the sky, catching the interstellar visitor sweeping past in the background like a faint, moving star. NASA's own Mars Reconnaissance Orbiter did the same thing, capturing its own images from a front-row seat no telescope on Earth could match. That closest approach happened at a distance of roughly 29 to 30 million kilometers, somewhere around 18 million miles. That is an enormous distance, dozens of times farther than the Moon sits from Earth. It was close enough, by interstellar standards, to be an exceptional scientific opportunity, a chance to observe this ancient visitor from an angle and proximity no Earth-based telescope could ever achieve. The engineering challenge behind those images is easy to overlook, but genuinely impressive on its own. Instruments like the Trace Gas Orbiter's camera were designed and built for one specific job: photographing the bright, close, well-lit surface of Mars from a few hundred kilometers up, not hunting for a faint, distant speck of light drifting slowly. against a field of stars tens of millions of kilometers away. Mission scientists have openly admitted they weren't entirely sure the attempt would even work, given how dim and how far away the target actually was compared to anything those cameras were built to photograph. It did work, producing a genuine, if grainy, series of images showing the interstellar visitor sweeping past in the background, exactly the kind of unplanned, improvised science that becomes possible only when a fleet of working spacecraft already happens to be sitting in the right place at the right time. It was nowhere remotely close enough to represent any kind of impact risk to Mars whatsoever. NASA's own scientists have stated plainly that the object's path never threatened Mars and never came close to threatening Earth either. Its nearest pass by our own planet in December of 2025 kept it at a distance of roughly 270 million kilometers further from Earth than the Sun itself. So why does the collision rumor exist at all? Most likely, it grew out of a garbled retelling of something that actually is true and actually is remarkable. This was the closest look at an interstellar object that any spacecraft has ever managed to capture, made possible only because humanity happened to already have working robots stationed exactly where this ancient visitor chose to pass by. Somewhere between that genuinely exciting fact and a viral headline, close flyby seems to have quietly mutated into collision course, the way accurate but modest science headlines so often do once they start traveling. But stripping away the fake collision story doesn't actually make this object less interesting. If anything, it clears space for the part of this story that real scientists are still genuinely, seriously arguing about. Not every astronomer studying 3I Atlas agrees on what it actually is, and one voice in that debate has been especially loud, especially persistent, and especially difficult for the rest of the field to simply ignore. Avi Loeb, an astronomer at Harvard, has spent years arguing that unusual interstellar objects deserve more serious consideration as potential artificial technology rather than automatically assuming every strange visitor is just an unusual natural comet. With 3I Atlas, Loeb has pointed to its trajectory, a path that happens to bring it unusually close to Jupiter, Mars, and Venus in turn, as a pattern he considers at least worth investigating rather than dismissing outright. He has gone as far as suggesting the object could have been sent toward the inner solar system deliberately, by design, rather than drifting in purely by chance. It's important to be precise about where that idea actually sits within the scientific community, because Loeb's view is not the mainstream position, and the vast majority of astronomers studying 3I Atlas do not share it. Critics of that theory point out that unusual trajectories and close planetary approaches are exactly what you'd statistically expect. From time to time, purely by chance once you consider how many objects sweep through the solar system and how many planets happen to be sitting in their path at any given moment. They argue that reaching for an artificial explanation before exhausting every natural one risks getting the order of operations backward, and that extraordinary claims like this one require extraordinary evidence, not simply an absence of a fully settled natural explanation. The composition Webb detected, that unusual carbon dioxide to water ratio, the water ice, the dust, the tentative sulfur compound, is exactly the kind of messy, imperfect chemical signature you would expect from a genuinely ancient, naturally formed comet that spent billions of years drifting through the cold vacuum between stars, not the kind of clean, engineered signature most scientists would expect from artificial technology. Most researchers studying the object interpret every piece of Webb's data as pointing toward a natural, if unusually old and unusually well-preserved icy relic. But the debate itself, unresolved, publicly argued, playing out in real papers and real press conferences rather than quietly settled behind closed doors, is part of what makes this particular interstellar visitor different from the two that came before it. This time, there was enough data and enough disagreement over how to read it that the argument didn't simply end the moment the object faded from view. And soon, it will fade from view, permanently, this time for good. 3I Atlas made its closest approach to the Sun on October 29, 2025, traveling at roughly 250,000 kilometers per hour at that closest point, the fastest speed ever recorded for any object passing through our solar system. Having already swept past the Sun and past Mars, its path is now carrying it onward, past Jupiter around March of 2026, and from there, out past the edge of the solar system entirely, back into the same cold interstellar darkness it emerged from, never to return. Whatever this object actually is, however it actually formed, once it leaves, it's gone. There is no future mission planned that could catch up to something moving this fast on a one-way trajectory like this. Every scrap of data scientists manage to gather before it disappears is likely the only data on this specific object humanity will ever get to have. That's what makes the timing of Webb's involvement matter so much. A telescope built primarily to stare at galaxies so distant their light left billions of years ago happened to be available, precisely positioned, and precisely instrumented enough to turn around and study something moving directly through our own cosmic backyard for the brief handful of months this ancient visitor was actually close enough to observe in real detail. Miss that narrow window, and the questions this object raises simply go unanswered forever, filed away next to Oumuamua's own unresolved mysteries from 2017. Here's what makes an object like this genuinely difficult to sit with once you actually let the timeline sink in. Every human being who has ever lived, every civilization that has ever risen and fallen on Earth, existed entirely within the last several thousand years. A rounding error compared to the age scientists now suspect this particular chunk of ice might actually be. It may have been drifting silently through the empty space between stars since a period so early in the galaxy's history that the sun itself hadn't even finished forming yet, carrying a frozen chemical record of conditions from a part of the universe's history that no human telescope, no matter how powerful, could ever otherwise directly sample. And now, for a few short months, out of 10 billion years of complete solitude, it happened to drift close. Enough for a handful of scientists on a small blue planet to notice, point their instruments at it, argue fiercely about what they were looking at, and try to learn everything they possibly could. Before it kept moving and disappeared again, this time forever. There's a particular kind of loneliness built into an object like this, if you're willing to think about it that way. It carries no crew, tells no story on its own, and will never again come this close to anything capable of understanding what it actually is. Every other comet humanity studies in detail belongs to a family, part of an orbit, expected to return again on some predictable future date, giving scientists years or decades to refine their answers at leisure. 3I Atlas offered no such luxury. It arrived out of 10 billion years of silence, allowed a narrow handful of months for study, and is now leaving again, permanently on a schedule nobody controls and nothing can slow down. Whatever mysteries remain unresolved in the data researchers have already collected are likely to stay unresolved, filed away in archives for future scientists to revisit with better tools, the same way researchers went back to Voyager data decades later, or old, lunar radar scans, looking for answers that today's instruments and today's questions simply weren't equipped to find the first time around. So here's the real question worth sitting with, once the fake collision headlines get cleared away and only the actual verified science is left standing. If an object this old, this strange, and this scientifically disputed could sweep this close to us, get photographed by spacecraft already stationed at Mars, get scrutinized by the most advanced space telescope humanity has ever built, and still leave researchers publicly disagreeing about what it actually is, how many other ancient wanderers like it have already passed through our solar system, unnoticed, in all the centuries before anyone had a telescope capable of catching one. And somewhere out past Jupiter, right now, 3I Atlas is still moving, carrying its unanswered questions with it, back out into the dark it came from. Whatever the true answer actually is, it may be leaving with it, this time for good.